Problem 1, here is a difference of cubes, and you've got to write it as 2 things cubed. So we can go to our sheet down here, and I can look up 27 in my cubed column, and 27 is a 3 cubed. So I'm going to put a 3, and I got to put an x in there also. And then 64, so I go to my table over here again. I pull up 64, and 64 comes from a 4 that's cubed. So I know 64 in the little box is a 4 that's cubed. And now we can say A is 3x and B is 4. And so here's the formula for a difference of cubes. Remember, I'm just stealing it from the sheet right there. So it's A minus B times A squared plus AB plus B squared. And let's plug in or substitute. So every time I see an A, I'm going to put a 3x. So this is how it would formally look. It'd be 3x minus sign, then comes B, and B is just 4. Then it says take the 3x and square it. So you do have to be careful here. It means this. Take the 3x and square it like that. So I'm going to start rewriting this line now, 3x minus 4. And I'm going to take the 3x and square it, which gives me 9x squared. And then it next says add on A times B. So it's like 3x times 4, which is 12x. And then lastly, if we can move this guy out of the way, we'll do our last term here, and it says put in a b squared. So b is 4, so I put in 4 squared, and that would be 16. So there is my factorization. Problem 2, and I'm going to grab my factor sheet here. I'm going to need him for problem 2. And it's a factor problem, so I'm just going to start up here and look for a GCF first. And then it's 2 terms, 3 terms, or 4 terms. This one's clearly got 4 terms. 1, 2, 3, and 4. Okay? So I know how it's going to factor. I'll first check for a GCF. I can take a 3 out of this one, but not this one. So I'm done looking for numbers to take out. I can take out x cubed. This one says nope, you can only take out x squared. This one says you'd only take out x. This one says you can't take out any x's because he doesn't have them. So I can't do any x's, and so I'm right here on my sheet. And it tells me what to do, starting with a group the first 2 terms. So I'm just going to get this guy out of the way, and let's start grouping. So my first 2 terms, 3x cubed plus x squared, grouped together, and my second 2 terms grouped together, negative 27x minus 9. Now I'm going to look for the greatest common factor within the group. So in this group, these 2 do have an x squared in common, so I'll take that out, leaving me with a 3x plus 1. Notice I do check this to make sure. I go x squared times 3x is 3x cubed. X squared times 1 is x squared. Then comes my plus sign, and then I factor the black one here, and I've got negative 27 and negative 9. So I might pull out a calculator at that point. Okay, if you're not good with your greatest common factors here, you could just ask your calculator, what is the GCF of your 2 numbers? In this case, we've got a 27 and a 9. So that'll tell me what it is, 9. Now I want to take a negative 9 out of this, because that gives me a positive 3x and a plus 1. And see, now these 2 factors match each other. They're both 3x plus 1s. So that's the common factor that the 2 terms have. When I take it out of the first term, I have that x squared left. When I take it out of the second term, I have that minus 9 left. And frequently I'd be done, okay? But if I look at this this graph here real quick, 3x hat cubed and plus x squared minus 27x, there we go, minus 9. We can see it's got 1, 2, 3 solutions, but I only have 2 factors here. And I see those other two solutions, the -3 and +3. I'm thinking this thing probably factors more. In fact, I know it does. This is a difference of two squares. And that's on our formula sheet as well. So our final answer is the 3x plus 1. And difference of squares, you just square root the x squared and square root that 3 squared, just x minus 3x plus 3. And there's our complete factorization, and now it gives me all those solutions that I see up here on the graph. It's number 2. Here comes number 3. Show that x plus 3 is a factor of this big polynomial. Here's the idea behind it. I'm going to take x plus 3, I'm going to divide it into f of x, that big long equation. I'm just writing it as f of x to indicate I mean this whole thing here. And if my remainder is 0, that means x plus 3 is a factor. But to do that division, I'm going to use synthetic. So I put a -3 in the box, and I write down my coefficients. I got 1x to the 4th. I've got 3x cubes. I don't have any x squareds in here. And so they should, maybe put a 0x squared in there to warn you ahead of time, saying there's no x squareds. Then there's minus 8x's, that's the next term's coefficient, and then minus 24. Okay, and so let's review real quick here how to do synthetic. I'm going to skip a line and draw a line here. And step number 1 is you bring the 1 down below the line. Now your divisor up here, the -3, there's your multiplying line. And you put the answer of the multiplication up here underneath your 3 in your next column. So I do 1 times, or -3 times 1, which is -3, and I park it right underneath the next column. And then this vertical column that you produce is always your addition column. So you just add straight down. 3 plus -3 is 0. And now we start the process over. You take your -3 now times the 0, and put your answer in the next column. That's 0, and then I add that one. I do this again. I multiply along that diagonal, and I get 0 again, and I add the column. And I multiply my last time, I get positive 24, and I add my column. And this is what we wanted. Yes, now we can say x plus 3 is a factor of f of x. It went into it evenly, divided in evenly. And even better than that now is we've started to factor this. Okay? Now, one of my factors is clearly the x plus 3 that I just proved was a factor. The other factor comes from this answer. So I started with an x to the 4th, and I've divided out x to the 1st. And so when I do that division, I will get an x cubed answer. So this 1 out here must be in front of an x cubed. The first purple 0 is in front of an x squared because we go down by 1 degree. The red 0 is in front of an x, and the constant is this -8 at the end. So these two terms aren't even in my polynomial. So I just have x cubed minus 8. And then I check to see, hey, I've done one factorization. I've got it written as these two product, or this product here. But does either one of these factors factor further? And I can see here I've got a cube, so it might factor as a difference of cubes, and it turns out it does, because this is like an x cubed minus a 2 that's cubed. 2 times 2 times 2 is 8. And so I'm just going to use the same factorization that we used way up here at the beginning and got this answer. But I'm going to use it on this one, and I'm going to go, I got my x plus 3, should have done that in red. And I'm going to go a minus b. So my a here is x, and my b is -2. Oops, not -2, just positive 2. The negative sign is in the formula. X, a minus b, a squared, plus a times b, 2 times x, plus b, which is 2, and you got to square it to get 4. So there is my product, or my factorization. Number 4, find the real solutions. It even gives me a hint, says use your calculator. So I'm going to graph that thing and just look to see if I can find the solutions. Remember, when you graph it, just graph the equation. Don't set it equal to anything. You're going to use your eyeballs to find out. That's the part you have to do. So I've put in my x cubed plus 5x squared. In comes minus 18x minus 72. Ooh, gee, but now I goofed that thing up. Minus 18. Nope. There we are. 18x minus 72. There's my solutions. It looks like -6, -3, and 4 are what make it equal 0 here. That's what they asked. And so my graph, on my graph, that just means find the x-intercepts. X could be -6, or x is either a -3, or x is a 4. And, you know, you could test these things. This is function f of x. And then you could just ask your calculator, you could check these ordered pairs. So you could say, hey, does -6 make it equal 0? And you say, yep, it does. And you could test the -3, yes, it does. And you could even test the 4, yes, it does. So those are our solutions. Number 5, let's factor this guy, because it says to. So I'm going to run through my factoring sheet. It says look for a GCF first. GCF. And I go to my calculator if I don't know the GCF. And I don't know there is one. I put in my two numbers. I've got a 100 and a 36. 4. So I take a 4 out. And 100 divided by 4 is 25. And 36 divided by 4 is 9. Okay. Step 2. I look at what's left over and go, do I have 2, 3, or 4 terms? Well, I clearly have 2 terms. So if it's 2 terms, it's either a difference of squares or a difference of cubes. It can't be a sum of cubes because this is not a sum. It's a minus, a difference. So it's either one of those two. It can't be a difference of cubes because 9 is not a cube. 9 is 3 times 3. It's a perfect square. 25 is also a perfect square, 5 times 5. So this is going to be a difference of squares. Now it's a little awkward because of this x to the 4th. But we can deal with that pretty easily by saying instead of 5 times 5 or 5x and 5x, making them 5x squareds. Okay, so now when they multiply, you get 25, 5 times 5, but you also get x to the 4th, x squared times x squared. And the 9 has to be a 3 times 3. And they have to have opposite signs so that they add up to 0x squareds in the middle. Okay. You could remultiply it and check it, but that is exactly the factorization. We're done right there. And finally, number 6 on this page. I'm not going to go through all the reasoning again because this is just like number 3. I'm going to use synthetic division with a -8. Remember, it's always the 0 or the opposite sign that you put in there. -8 makes it 0. That's why we call -8 the 0. And then I write down my coefficients. I've got 1x cubed. Let's do it in blue here. 1x cubed, 11x squareds, 6x's minus 144. And if it's a factor, then our remainder is 0. Okay, so I'm going to skip a line, draw a line, and I'll bring down the 1. Here's my multiply. Here's my answer. Here's my add. Okay, and I'm going to repeat that. So I'm going to go multiply, put my answer. -8 times 3, -24. Add those up. They add up to -18. -8 times -18 is a positive 144, and they add up to 0, so yes. X plus 8 is a factor. F of x, okay. And now we have it factored. It's x minus 8, plus 8, the first factor. And then the answer, now this answer I started at x cubed, so now this is x squared, 3x's minus 18. So x squared plus 3x's minus 18. And normally I would, or not normally, just many times I'd be done here, okay? But this quadratic might be factorable. It's got 3 terms. So I've got my x plus 8, but this trinomial here, regular old quadratic, those things generally factor in our book problems. Now r times s here, they got to multiply to give you this 18. So I can use a 1 and an 18 or a 2 and a 9 or a 3 and a 6. But I want them to have a difference of 3. So I want plus 3 and minus 6. And then those two add up to a positive 3. So I'll go minus 3 and plus 6. And there we go. There's my complete factorization. Okay, side 2 here. Piece of cake on number 7 here. According to the complex conjugate theorem, what's another solution? Hey, they gave us x is negative 9. What you have to remember is we said these things always come in conjugate pairs. So if negative 9 is a solution, then, or negative 9i, so is positive 9i. Now we usually don't show the plus sign, so we just write 9i. But the complex conjugates, a plus I root b, and a then minus I root b. They only change or have that one sign that's different. And this conjugate theorem just says if you get the plus 1, then you automatically have to get the minus 1. Or if you get the minus 1, you have to get the plus 1. So if like 3 plus 4i is an answer, then 3 minus 4i is an answer. Conjugate pairs. If 5 plus root 2 is an answer, so is 5 minus root 2. And this list could go on and on. Notice they don't always have to have imaginary numbers. It's the radical part that always comes plus minus pairs. Remember, I is root negative 1, so it's a radical. And we get a plus of the radical and a minus. Get a plus of the radical and a minus. It could even be more complicated, like negative 7 minus 5i root 2. Okay, here's the imaginary section. And so if it has a minus imaginary, it also has a plus imaginary. So negative 7 still, but now plus 5i root 2. Okay, so regardless of the problem you get, you should be able to find its conjugate pair. Number 8's a solve the equation problem. So you can go right to your calculator and just try to see if you can find the solutions. X hat cubed minus 6x hat squared, and then plus 9x. And when I graph it, I can see I get 2 answers right away, 0 and 3, but this thing is supposed to have 3 answers because it's x cubed. Let's try and factor it. So I look at my 3 terms here, and I can certainly see they all have an x in them. So I would pull that x out, leaving me x squared minus 6x plus 9. This is a trinomial, 3 terms, and so it can very frequently factor. Got my x still sitting out front. See here, it had to be x times x to give me x squared, and blank times blank has to give me 9, so it could be a 1 times 9 or a 3 times 3. But they got to add up to negative 6 in the middle, so they both got to be negative 3s. And now it's actually consistent with my graph that I did. So x could equal 0, or the first x minus 3 could equal 0, or the second x minus 3 could equal 0. But these last two give you the same answer. X is a positive 3. But that is multiplicity. That means that 3 counts twice. And that's why in your graph it just touches the x-axis and turns away. So our answers for this thing are x is 0 and 3 with multiplicity 2. Or you could write 0, 3, 3, something like that, to show you found all 3 of them and 2 are the same. And finally, number 9, find the zeros of this polynomial and sketch the graph. So if they want me to sketch a graph, I'm just going to type that equation in. X to the 4th minus 8x squared plus 16. Oh man, look at that. Oh, and they're just touching and turn away. So it looks like at negative 2 and positive 2, I've got solutions. And because it touches it and turns away, that's multiplicity. And if they both have multiplicity of 2, which the graph shows they do, then I know I've got all my solutions found. Let's see how high this graph goes. It goes up to 16 up here, it looks like. Well, my table or my graph paper here only goes up to 10 if you look at it. So I'm not going to be able to get the peak in here. Okay? And again, we're not too concerned about maxes or mins right now. We just know it starts right there. It's going to go way up here. Maybe we'll put a 16 up there, something like that. To say, hey, I'm going to 16. Okay. Doesn't super matter. That part doesn't. What we're concerned about is do you have those zeros? So it looks something like this. Oops, that left side was pretty weak there, so we'll hit undo. We'll give it another shot. There we go, and we'll kind of pull him up like that, something like that. So he's a big W, and the key thing is these zeros down here. But we solved it, and we've graphed it. Just a sketch. All right, that's what your test looks like. Hope that